Hi, my name is James Kelly, and this is my overview of Lab 1, Charged Tape. Introduction. The purpose of this lab is to use tape in order to observe the transfer of electrons between different surfaces and to calculate an estimate of the transfer of electrons. Also, we will experimentally determine the charge that a piece of tape holds by measuring the distance between two pieces of charged tape as they begin to repel each other, making one float above the other. We will then compare that result to a computational model which calculates the charge required for this observation by treating the system as a point charge. The main physics principles for this lab are Newton's second law, the force due to gravity, Coulomb's law, and net force. In this case, a combined net force from gravity and the electrostatic force between both pieces of tape. Results of the experimental model. A brief overview of the results are as follows. Both models found that the charge of the tape was about 4.784 times 10 to the negative 9 coulombs, which is a positive charge. Furthermore, it was found that the efficiency of electrons on one piece of tape was negative 2.99 times 10 to the 10 electrons, and the calculated force of gravity and an electric field was 0.00133 newtons. During the investigation prior to the experiment, it was observed that the pieces of tape repel each other but attract to a negatively charged plastic pen, meaning the tape holds a positive charge. Conditions of the experiment. System and surroundings. The system is tape B, and the surroundings are the universe around it as well as tape A. Initial conditions. The initial conditions are tape B at rest, being held up at each end with the only initial force applied being gravity. For all calculations, it is assumed that tapes can be considered point masses or point charges. This is because the two tapes, being identical in size and mass, should be given the exact same charge when the charging process is performed. When also assuming that the charges are evenly distributed across the surface of the tape, it makes it possible to consider the system as 2 point charges. Data and calculations. It was found that the mass of the tape was 0.0001152 kilograms. The length of the tape was 0.14 meters, and the width of the tape was 0.02 meters. It was observed that the tapes started to repel each other at 0.0135 meters. The force of gravity on tape B was calculated to be 0.00113 newtons. Since the tape is stationary, where the acceleration equals 0, we can say that F tape equals F grav, basically meaning that the force due to the electrostatic and the force due to gravity cancel out. This is then used to solve for the charge of the tape, using Coulomb's law and algebraically inserting the net force. The number of electrons lost by the tape is equal to the charge of the tape divided by the charge of a single electron, which is the known quantity, which results in 2.99 times 10 to the 10 electrons. The area of the tape can be found with the length times width, which was found to be 0.0028 meters squared, and the area of the atom is found by the squared of the length of an atom, which is a known quantity as well, which results in 1 times 10 to the negative 20 meters squared. Therefore, you can also find the number of atoms on tape, which was found to be 1.13 times 10 to the 17 atoms. This results in an electron to atoms ratio of 1 to 9.36493 times 10 to the 6. This is the code used for the computational model. Essentially, what the code does is calculate the gravity and algebraically solve for the charge of the tape, in this case represented as a point charge, using Coulomb's law. Discussion. Overall, it was recorded that there were very similar results from the experimental and computational models. In this case, they were identical, with the charge of the tape being found to be 4.784 times 10 to the negative 9 for both models. Furthermore, the electron efficiency was also identical, being negative 2.99 times 10 to the 10 electrons. Sources of error. One key source of error is the fact that the two tapes were not the same. They had slightly different masses, lengths, and charges. It is also highly probable that there was not a uniform charge on the surface of the tapes, meaning that modeling them as point charges is inaccurate at best. Further, modeling tape B as a point mass is also inaccurate, as the tape itself has connection points to where it is being held up, indicating additional forces are acting on it in different spots, not just gravity. What if electrons had positive charge and protons had negative charge? What would change about the observations made with tape and other objects? Nothing would change about the experiment, as opposites would still attract and likes would still repel, leading to the same conclusions being drawn, just with electrons and protons swapping places. Why is it important to handle charged tapes as little as possible? This is important because the more interactions the tapes have with other objects, the more charge it loses. That means that every time it touches an object, electrons are transferred from surface to surface, depleting the strength of the charge of the tape. This matters because it makes it impossible to assume two tapes will still have the same charge after a number of interactions with other objects. Thank you.